In this video, we solve an integration problem that requires us first to do long division and then partial fraction decomposition. So we have the following. Integral of x cubed plus 6x squared plus 3x plus 16 divided by x cubed plus 4x dx. So first, we say notice that the degree of the numerator, which is 3, is the same as the degree of the denominator for the integral. Therefore, we cannot just go ahead and do partial fraction decomposition or factor the denominator. We need to do long division so that until we get the degree of the numerator less than the degree of the denominator. And here is how we perform the long division. The denominator will put it on the left-hand side. The numerator will put it inside. So if you take x cubed divided by x cubed, it gives you 1. So 1 will be our first result for the division. So you take 1 and multiply every term by 1, and then flip all sign, because you multiply by 1, you get x cubed. Multiply by 1, you get 4x. So align the x cubed and the term in x, and then flip the sign here and do the just add. So get negative x cubed minus 4x. Then we have 0x squared on this line, so we have 6x squared divided minus 0, which is 6x squared. We have 3x minus 4x, which is negative x, and then you bring the 16 down. So now, as the degree here is 2 and the degree there is 3, so we cannot divide degree 2 by degree 3, so you will stop there. Therefore, we can rewrite the integrand as 1 plus the remainder here, divided by the quotient, divided by the denominator. So, and that's what we get here. The next thing now, we do partial fraction decomposition on this expression, because the numerator degree is less than the denominator degree, and that will lead us to obtaining, first factoring the denominator. We get x factor to x squared plus 4. Note that x squared plus 4 cannot be reduced to lower term factors or product factors or factors of linear terms, because it is irreducible. Now next, we write this term as a over x plus, because we have x squared there, we should and the expression is irreducible. We have bx plus c on the numerator. So we want to find a, b, and c. So reduce everything to the same denominator, to a common denominator. In doing so, we get a plus b x squared plus c x plus 4a. So where is a plus b coming from? You have ax squared and bx squared. So factor out x squared, you get a plus b. Then you have cx, and also have 4a here. So that's what we have there. Now, matching the coefficient of like term on the both numerators, we have a plus b is 6, c is negative 1, and 4a is 16. And that's what our system here gave us. So a plus b is 6, c negative 1, 4a 16. So solving for a, we get 4 by dividing by both sides by 4. And now b is going to be 6 minus a, which is 6 minus 4, which is 2. So a is 4, b is 2, c is negative 1. Now rewriting the integrand, we obtain x cubed plus 6x squared plus 3x plus 16 divided by x cubed plus 4 is 1, that we obtained earlier. And then the partial fraction for the other term b is, okay, a is 4 over x plus, b is 2 bx, 2x minus, c is negative 1 minus c divided by x over 2. But now see that when you'll be integrating, you have an issue here, because the derivative of x squared plus 4 is 2x, not 2x plus 1. So it's important for us to split this term as 2x over x squared plus 4 and minus 1. So that's what we do here. Now realize that to integrate this, if the derivative of the denominator is the numerator, therefore we do change our variable u equals x squared plus 4 you get du is equal to 2x dx, and therefore that is ln of the denominator. And here we already have an idea of what the integral of this is going to be, and the integral of this also know. So the integral of 1 is obvious. So finally, the given integral is here, and we can write it as integral of 1 plus 4 integral of 1 over x plus integral of 2x over x squared plus 4 minus integral of 1 over x squared plus 4. Integral of 1 is obvious, it is x. Integral of 1 over x is ln of x, and integral of 2x over x squared plus 4 is ln of x squared plus 4. And the integral of 1 over x squared plus 4. Remember the integral of, if you take the derivative of r tangent of x over u over a, is going to give you a squared over 1, a squared divided by 1 plus this. And so we learned that the integral of 1 over a squared plus x squared is 1 over a tangent inverse of x over a, then plus constant. So don't forget the constant term here. And that completes the evaluation of this integral.